Hello everyone, this is Dr. Esperanza and today we're going to be working on analyzing rational function and the app that I usually use to verify if my analysis is correct. Analyzing rational function can be intimidating because there's so many properties, formulas that we need to know to be able to write the correct analysis for the graphs of our rational functions. And for today, to be able to help students and teachers to understand the beauty and the challenge of analyzing rational function, we're going to be talking about the apps that I usually use in working and understanding rational function using technology. So analyzing rational function can be challenging. So the videos on this particular lessons will be in the description box below that you can use and you can practice on. And for teachers, you can share and use this video to help students understand and appreciate how to analyze a rational function. And the first thing that we need to work on when working with rational function is, of course, to remember the factoring techniques that we have learned from algebra. So from finding the GCF to using the big X method in factoring quadratic equations and all different techniques that we have learned in factoring special products. We're going to be using that in analyzing rational function because that's how we find and figure out the domain and range of a rational function, horizontal and vertical asymptotes of a rational functions, the x and the y intercepts or the solutions of the rational functions, the slant asymptote sometimes, and of course the point of discontinuity when we're working with rational functions. Now take note that not all the time you will find every single item in the list that I have shown you. Sometimes horizontal asymptote exists, sometimes it doesn't, and some other parts of the rational functions exist, and sometimes it's not existing. So it all depends on the behavior of your rational function, which what we're going to be working on today so we can analyze this rational expression or equation that we have here right now. So don't worry about how quick my solution is because, again, the main focus is how to use the application that will verify our answer. So let's just quickly answer this particular problem by first finding the factored form of our rational function. And the factored form of the numerator and the denominator, good thing that they are both factorable. So the factors of the numerator would be x, negative is the last term, so we have positive and negative. So we have here negative 3 and positive 2 as the factors of the numerator. And for the factors of the denominator, so we have x, and we know that they are factorable because I already solved this a while ago, and I chose this particular function so that it will highlight all these parts right here. So we have positive and negative 3 and 1 because negative 3 times 1 is negative 3 and 1 plus negative 3 is negative 2, and this is the factored form of our denominator. And now that we have the factored form of our rational function, we can now find the domain, solution, and so on by first working on the zeros of the denominator. So the domain can be found by setting the denominator equal to 0, and by doing so, we'll have x plus 1 equal to 0 and x minus 3 is equal to 0, and we know that we'll have x is equal to negative 1 and x is equal to positive 3, and just like what I always tell my students, this particular technique in analyzing rational function is finding the virus that will make our denominator 0 because it's fatal in rational function because once our denominator is 0, our function will no longer exist. So now that we have found the viruses, which is negative 1 and 3, so we know that our domain will be all real numbers such that x is not equal to negative 1 and x is equal to or not equal to 3 because that will make our function undefined. So now that we found the domain, by setting the numerator to 0, we'll be able to find the solution of our function. So solution in our rational function will be numerator equal to 0. So the zeros of our numerator is going to be x is equal to -2 and x is equal to +3. However, before you can choose if both of them will be a solution, you need to check our rational function first. Notice that we can cancel out x minus 3 and x minus 3. And with that particular technique, we know that we can eliminate this as our solution. And the solution of our rational equation is at x equal to -2. So what will happen to x minus 3 and x minus 3 right here that we canceled out? That will be our point of discontinuity. So if we set it to 0, x minus 3 is equal to 0, as x is equal to 3. So the point of discontinuity of our function, which means our function will not exist. It cannot be an asymptote nor a solution at x is equal to 3. And speaking of vertical asymptote, our vertical asymptote can be found using the remaining denominator that we have here. And x plus 1 is equal to 0. 0 will give us x is equal to -1. Therefore, our vertical asymptote is at x is equal to -1. And now the only thing that is left to fill in is the horizontal asymptote. And the horizontal asymptote, it's found by using our properties, and it all depends on the highest or the degree of your numerator and the denominator. And since the degree of our numerator and denominator are the same, which is quadratic or x raised to the second power, the coefficient of the top is 1, the coefficient of the bottom is 1. So our horizontal asymptote is at y equals 1. And again, there are 3 properties that you need to know to be able to find your horizontal asymptotes, and it's in the description box below. So know when you will have y is equal to 1 as your horizontal asymptote, when is a horizontal asymptote does not exist, and when is the horizontal asymptote equal y equals 0. And again, it's in the formula that you need to know. And now that we have this analysis, this beautiful work of art or mathematics, we can now use our application, which is in the description box below, and we'll be able to verify if our analysis is correct. So we have done it by hand. Now let's see if our analysis is correct by graphing it using this app. So we have x squared minus x minus 6, and that's our numerator, and the denominator is x squared minus 2x minus 3. And now that we are seeing the graph, we'll verify it. Let's add x is equal to 0, or the function equal to 0, because this little app right here can be temperamental at times, but we can see that our analysis is correct because this is our point of discontinuity at x is equal to 3, which is a check from our work right here. Our solution is at x equal to -2 right here. And our y-intercept, if you set your y to 0, it's at 2. And the horizontal asymptote, it's going to be at y equals +1. And the vertical asymptote is at x is equal to 1. And you'll be able to verify it by looking at the solutions of this equation. And you can also see the solutions right here if you take the full version, but we don't need the full version because we know how to do it by hand. We're just using technology to verify if our answer is correct. So symbolab.com is the application that I use to verify if my analysis is correct, and you can try it later after this video so you can analyze your rational function just like how we analyze this right here. So you can see that our analysis right here is verified and correct. If you want to check it, you can use the app later and plug it in, and you will see that these are all visible in the graph of our equation. So this is how we work on the analysis of our rational function using an app. So again, you need to understand how to use your factoring techniques to be able to analyze your rational function. And of course, the parts of the graphs of your rational function so you can understand how factoring and the properties work to be able to analyze your function, specifically rational functions. And for teachers, do you have any app that you want to share on how you verify your work when you're working with rational functions or maybe calculator that you use? And to the students who are watching our video today, you can use our examples in the description box below so you can verify your own rational functions. Use the application that I have just shown you so that you can check your work, especially if you don't have your teacher right next to you or your smart friends that can verify that your work is correct. So this app will help you gain confidence in working with challenging math problems like this. And again, practice makes perfect, and make sure that when you're practicing, you're doing it correctly. So use the app. It's not cheating. It's only cheating if you're dependent on the app without really understanding how the app works. This is Dr. E, and see you again next time. Bye!